Hi, my name is David Chuka, and you're welcome to View Mastery's Quick Test with Vitest. Testing is integral to many large web applications because software is dynamic with a lot of moving parts and requirements that tend to evolve over time. Essentially, we write tests to identify potential bugs before shipping an application to its users and also to improve the maintainability of our codebase. In this course, we're going to take a look at Vitest. Vitest is a modern unit test framework powered by Vite. It has a similar syntax to Jest and comes equipped with ESM, TypeScript, and JSX support right out of the box. Some interesting Vitest features include a built-in test runner, snapshots, code coverage, smart and instant watch mode, and more. Don't worry if you're not familiar with some of these terms. We're going to learn all about them and more in this course. So, why Vite? Vitest was created to provide a leaner and faster development experience for modern web projects, with native support for common web patterns such as dynamic import syntax and server-side rendering capabilities. Vite's numerous plugins and integrations are fostering a vibrant ecosystem, but this has led to a new problem: writing unit tests for Vite-powered applications. Using testing frameworks like Jest to test Vite-powered apps has led to many duplicate configurations between Vite and Jest. Vite solves this by removing the extra configuration needed to write unit tests, as you can now reuse the same Vite config and plugins across your app and your tests. In this course, we're going to combine Vitest and Vitest utils to test a Vue app. Although we'll be testing a Vue application, it is important to note that Vitest is framework agnostic, and so the same concepts should apply across other frameworks as well. Here are a couple of things we're going to be learning in this course. We're going to learn how to set up and test our components using Vitest. We're going to learn how to mock API calls during testing. We're going to learn how to test our entire application. And finally, we're going to learn how to migrate our entire app from using Jest to using Vitest. Ready to get started? I'll see you in the next lesson. In this lesson, we're going to write our first unit test using Vitest. At the end of this lesson, you should know how to set up and configure Vitest in a Vue app, standard Vitest methods that exist, and how to write and run tests using Vitest. The code for this lesson is available for you in the lesson resources below. To code along, simply clone the repo and make sure to install its dependencies. So, what are we going to be testing? Our demo component is a simple toast notification that can display 3 different types of notifications, namely info, error, and success, depending on the specified status. So now that we know what we're going to be testing, we can go ahead and set up Vitest. We can install Vitest using the Create View utility or set it up manually by installing the package in an existing project. Because we will be expanding on this project later on in the course, let's use the Create View utility to set up our app. Let's run yarn create view and then the name of our project. Alternatively, you could use npm. We'll say no to everything except Vitest, ESLint, and Prettier. cd into the project folder and run yarn to install all the dependencies. Now that we're done setting up our project, let's take a look at Vitest configuration. If you take a look at our project, you will notice that 2 configuration files have been created for us: vitconfig.js and vitestconfig.js. Although we can configure Vitest in either of these files, the vitestconfig.js file maintains a higher priority and will override the configuration from vitconfig.js. For the remainder of this course, we'll be working with the vitest.config.js file that has already been pre-configured for us with some defaults. Vitest also allows for extra configuration which can be found on the config page of the docs. We're now ready to run our first test. If you take a look at the components folder, you should see a folder named test that contains a single test file titled helloworld.spec.js, which tests the helloworld.view component. This folder, along with the files, were automatically created for us in our project during setup. Vitest identifies test files by using the .spec.js or the .test.js file extension. Looking at this test file, you may not be familiar with some of the keywords and functions that appear in the code, But don't worry too much about that because we'll be exploring their functions and definitions in detail later on in the course. We can find the script to run our test in our package.json file. This command looks for tests, essentially files ending with .test.js or .spec.js in the src folder and executes them. For simplicity, let's rename the command to use just test by removing the unit suffix. Now, we can run the command in our terminal. We can see that the test in hello world.spec.js successfully runs and passes. Now that we've successfully run a test, let's try and replicate this result by writing and running our first test. We're going to write a simple test that asserts if the square root of a provided number is correct. Let's create a new file in our test folder called squareroot.test.js. First, we'll import 3 functions from Vitest: describe, it, and expect. As it sounds, this function describes what we're testing. It is fully optional and will appear in our test output when we run our test. The describe function can also be used to group related tests together. Inside of the describe block, we're going to add the it function. The it function houses our test validation or assertion code block. The first argument is a string that reads like a sentence with it or test. So in our case, it finds square root. And the second argument is an arrow function that contains the assertions. This is where the actual testing takes place. We write statements about how we expect our code to behave. The expect function accepts valid JavaScript operations as arguments and returns an object that represents different forms of assertions. A full list of assertions can be found in the Vitest documentation. In our case, we want to check if the square root of a given number is what we expect it to be. For example, we're expecting the square root of 49 to be 7. When we run our tests using the yarn test command, we should see an output showing that 2 of our tests passed. If we expected the square root to be something wrong, like 8, we would see the test fail. As you can see via the assertion error, we told our test to expect the square root to be 8, but it actually received 7. Thus, it failed. Also, if you notice, anytime you edit your test file, the test automatically recomputes the result and reruns it in the terminal. This is because Vitest comes with instant watch mode that watches for changes in our test files and reacts accordingly. In this lesson, we learned how to set up Vitest and write our very first test. Although this was an introductory example to get you familiar with testing, in the real world, you will most likely be testing the components that make up your app. And so, in the next lesson, we're going to be testing our notification toast component to validate that it works as expected. See you in the next lesson. In the last lesson, we learned how to set up Vitest in our project, and then we wrote a simple test to check the square root of a number. In this lesson, we're going to build out our notification component and test that it works as intended. To focus on testing, I've already built out our component. You can copy the code for the component below or from the GitHub repository in the lesson resources. Let's create a new file in our components folder called notification_toast.view and add the following code to it. This is a simple component that can display notifications to the user. It accepts 2 props: status, which specifies the type of notification, error, success, or info, and message, which is the text to display in the notification. Our component also emits an event to clear the notification whenever the close button is clicked. Let's display this component in our app and confirm that it works. Inside of our app.view file, we'll import ref from view, as well as our notification toast component. We can then set a default value for our message prop. We'll create a clear notification function that sets our message value to an empty string. And finally, we can now display our notification toast component in our app. Let's head over to our terminal to run our app using the yarn dev command. If we visit our app in the browser, we can see our notification toast component being displayed. There may be instances where you need to test a component independently without all of its features. Vitest Utils provides a set of utility functions and methods to mount and interact with Vue components in an isolated manner. This dummy component is called a stub, and to use a stub in our test, we will need access to the mount method from Vitest Utils, the official testing utility library for Vue.js. Let's install Vitest Utils into our app. We'll run yarn add dev Vitest Utils. Alternatively, we could use npm. We'll also need to be able to emulate a browser environment while testing. This will give us some access to some browser APIs and will allow us to be able to test our components without interference from the actual environment. In our case, an actual browser. Vitest currently supports two packages that can help us achieve this: HappyDOM and JSDOM. If you open your package.json, you'd see that we've had JSDOM installed for us automatically during setup. JSDOM has also been configured as our environment in our vitest.config.js file. Now that we've built out our component and installed the necessary dependencies, we need to decide what features of our component we'll be testing to ensure that it works as intended. Our tests need to check for the following. First, that the component renders the correct style depending on the notification status. Second, that the notification slides up when the message is empty. And finally, that the component emits an event when the close button is clicked. With these goals in mind, we can start writing out the tests for this component. Let's create a file called notification_toast.test.js inside our test folder and set it up for testing. First, let's import the mount method from Vitest Utils, our notification component, and the three main Vitest methods that we discussed in the last lesson. Let's initialize our test suite with the describe method. In our test file, let's create a new test block for the first test. Our first test checks that the style of the notification rendered matches the notification status. That means if we get an error notification, we expect the background color to be red, success will be green, and info would be blue. We want to create a variable called status, which is a reference to the status prop we use in our component. We can then assign the value of error to it, which is the notification type we're currently testing for. The next thing we want to do is create a variable called wrapper, and we'll use mount to stub our component for the purpose of testing. Mount accepts two arguments. The first is the component we wish to replicate the functionality of, and the second is a list of options. These options provide different properties that ensure our components work as they would in the browser. In our case, we only need the props property because our notification toast.view component needs at least one prop to function correctly. After adding this option, we pass in the prop that we need. In this case, we only have a status prop. We can finally write an assertion to conclude our first test. It's going to check that the notification component renders the correct style for an error type notification. We'll use the expect method, which accepts our stub component with all the options. In our case, we've named this stub component wrapper for easy reference. We're going to check that the component's class list returns an array that includes the notification error class. We can achieve this by using the classes function, which returns an array containing all the classes for that component. Now we can assert that the notification error class exists in this array by calling our toEqual function, which basically checks that the value x is equal to y. Let's run this test to confirm that it's passing. Let's go into our terminal and run the yarn test command. Now that that is passing, we can repeat the same process for the other notification types, success and info. Now we'll rerun our tests to confirm that they all pass. Now that we're done with our first test, let's get started with writing our second test. According to our code, when users click the component's close button, we emit our clear notification event that resets our message prop to an empty string. We're also adding or removing a notification slide class depending on the value of this message prop as seen in our code. Let's write a test that checks if our message is empty before it slides up. Set up a new test block and create a message variable with an empty string inside of it. Next, we're going to create a variable called wrapper, mount our dummy notification toast component, and pass this message variable into it as props. We want to check that when the message prop is empty, our notification slides out of the app. So, Let's write an assertion for that. We'll check the classes array of our component and ensure that it does not include the notification slide class, which is responsible for keeping our component in view. Now we can rerun our tests to confirm that they are all passing. In our final test, we want to make sure that the component emits an event whenever the close button is clicked. This is an important feature to test because we want to make sure that, apart from UI features, the functionality of our component works as intended. For this test, we're going to use an async function because we're going to be triggering an event which returns a promise, and we need to wait for this promise to resolve in order to catch the changes that this event would cause. Let's initialize this test with an async function as its second argument. In a similar fashion to our previous tests, let's create a wrapper variable and assign it to our dummy notification toast component. Our options argument is a data method and it returns a clicked property which would be toggled between true and false every time it is clicked. To trigger this click event, let's attach our button to a variable. Create a new variable called closeButton and use the find function to fetch the button. The find function is similar to the native query selector function in JavaScript, as it accepts either a class, an ID, or an attribute and returns an element. After finding our button, we need to trigger the click event. We can do this using the trigger function. The trigger function accepts an event, executes it, and returns a promise. For this reason, we await this action in order to ensure the changes to our DOM have been made before we make an assertion based on this event. So we want to make sure we use the await keyword before triggering the click event. Finally, we can check the list of events that our component has emitted using the emitted method, which returns an array of events. Like our previous examples, we will need to check that this array includes the clear notification event. Let's confirm that all our tests are passing. We'll also need to test that our component renders the correct message to the viewer. Let's head over to our code and set up a new test block. Create a message variable with a simple message. Next, let's mount our dummy component and pass that message as a prop. Our assertion is going to check if the right message is being displayed on the app. We want to find our message text using the p tag that displays our message and then check that its text is the same as our message prop. Please note that in most cases you'd want to replace the p tag here with a class name or an element attribute, but this will suffice for our solution right now since there's only one paragraph tag in the component. We can extract the content of the element using the text method, which is similar to the native inner text function in JavaScript. Let's assert that this value would be the same as the message using our toBe function. Let's run our test one more time to ensure that everything works correctly. In this lesson, we learn how to write unit tests for our view components using Vitest. In the last lesson, we'll also need to test that our component renders the correct message to the viewer. Let's head over to our code and set up a new test block. Create a message variable with a simple message. Next, let's mount our dummy component and pass that message as a prop. Our assertion is going to check if the right message is being displayed on the app. We want to find our message text using the p tag that displays our message and then check that its text is the same as our message prop. Please note that in most cases you'd want to replace the p tag here with a class name or an element attribute, but this will suffice for our solution right now since there's only one paragraph tag in the component. We can extract the content of the element using the text method, which is similar to the native inner text function in JavaScript. Let's assert that this value would be the same as the message using our toBe function. Let's run our tests one more time to ensure that everything works correctly. In this lesson, we learn how to write unit tests for our view components using Vitest and Vitest utils. We focus on testing our notification components to ensure that its UI and functionality behaved as expected. We also learn how to create dummy components that act as temporary replacements for our actual components so that we can focus on testing that component without worrying about some of its external dependencies. In the next lesson, we're going to be working on snapshot testing. See you there.